Hello again, algebra students. Today we're going to move on with solving inequalities. So far we've spent a whole day on just addition and subtraction inequalities. Multiplication and division was another day, and now we're going to kind of throw it all together just like we do with equations. If you haven't been in the habit of this, please write these examples down. I think it's going to be really helpful, especially with some of the graphing stuff we're going to talk about. In number one, again, if this was an equation, nobody would have any issues at all with how to solve this. And there's really no tricks today on this kind of problem with our inequalities. So let's start with our vertical line, just like we do for an equation. And I want to solve this for x. I want to get the x by itself. The 3 is attached to the x, so we're going to leave that alone. That's going to be the last thing that goes away. So we'll start by adding 2 to both sides. So 3x is less than 12, and then we're going to divide by 3. And I get that x is less than 4. Hopefully, through the last couple of lessons, now you're feeling pretty comfortable with the actual graphing part of this, knowing that this is going to be an open circle, knowing which way we're going to shade. Remember, as you're writing these down on your own paper, you can always pause it and try the whole problem yourself and then check it with me, or pause it if I'm going too fast. So I'm going to have 4 is my important number. We'll go 3, 4, 5. I maybe should have shifted it down a little bit, but that's okay. So open circle because it's only a less than. And we're going to be going to the left because, again, it's a less than. For number 2, I need to get the a by itself. And again, 4 is attached. Leave it alone. Let's get rid of the 8. And then we would divide by 4. So I'll get that a is greater than or equal to -2. And -2 is my important number. Make sure that your numbers are going the appropriate way on a number line. If you need to write down just a couple of numbers on either side of 0 to just remember which way your numbers are going, go ahead and do that. Because this has that half of an equal sign, it's going to be a filled in circle because it can be exactly equal to -2. And then we're going to go greater than, which is going that way. Number 3, I know some of you are looking at that and freaking out a little bit because of the fraction, but remember, it's just a division. But that -3, that's what's attached to the variable. So let's just leave it alone. I want to start by getting rid of adding 2. So I would subtract 2 from both sides. And I'm going to have b over -3 is less than or equal to 1. To get rid of dividing, we're going to multiply. Don't use the reciprocal. We don't want to put the b into the denominator. We're just getting rid of the dividing by -3. So I'm going to multiply both sides by -3. And I hope that you remember from the last lesson, because I'm multiplying by a negative, that's going to take this less than or equal to and flip it around to be a greater than or equal to. And 1 times -3 is just -3. This will be a filled in circle because it's equal. And I'm going to the right. These numbers are all bigger than -3. Now, I haven't really talked specifically about checking your answers, and I probably should have done that earlier than this. But if I pick anything that's in that shaded part, it should work. So I'm not going to be able to pick every single number, but pick a number that's bigger than -3 and make it easy. I would choose 0 if I can. So if I would substitute a 0 right here. 0 divided by -3, well, that's just 0. Plus 2 is 2. And my answer then would be that 2 is less than or equal to 3, which is true. In number 4, the negative in front of the fraction, I am not a fan of writing it that way. Not that it isn't clear, but it does tend to get lost if it's written that way. So I would suggest that you take that negative, and instead of leaving it where it is, let's just kind of float that down to the denominator. So I really have c over negative 2 minus 6 is greater than negative 8. And again, the negative 2 that's attached to my c, leave it alone. We're going to add 6. So c over negative 2 is greater than negative 2. So I'm going to have to multiply to get rid of the denominator, to get rid of the division. And again, multiplying by a negative, that's going to flip my sign. Negative 2 times negative 2 is positive 4. So if I have 4 right here, 3, 4, 5, we're going to have an open circle at 4, and we're going to be going to the left because we're talking about numbers that are less than 4. For number 5, we're going to be distributing first to simplify this. So when we do that, we're going to get that 8 is less than or equal to negative 4d plus a negative 4, or just minus 4. And then to get rid of the negative 4 that's being added at the end, I would use a positive 4. Again, if you had left that, instead of plus and negative, if you had left that as a subtracting 4, to get rid of subtracting, you would add. So that would get rid of it either way. So I've got 12 is less than or equal to negative 4d. This is going to be one of our double flippers. So I'm going to have to divide by the negative 4. And that'll flip my sign because I divided by a negative. And then I would say, well, I really want the variable to be first. So the alligator is trying to eat the negative 3. When I rewrite this, I still need the alligator to be eating the negative 3. When I graph that, I'll have negative. Those are my numbers. And I need a filled in circle at negative 3. And we're going to the left. Again, remember, when we get these problems that are double flippers, it looks like my sign didn't change. It looks like it started as a less than or equal to, and it ended as a less than or equal to, but remember, we really flipped it twice. Now, on these last couple of problems, we want to look at some other options that we have sometimes when we're solving inequalities. These first couple are just normal ones. There's nothing really big about those. I want to make sure that I'm careful when I've got variables on both sides. This is where we can get some strange situations, just like we do with equations. Be careful about this one because I've got a negative 2n and a negative 4n, and you guys know by now, I like to move the smaller variable, which is the negative 4n. So I would add 4n to both sides. So I'm going to get that 5 plus 2n is greater than 8. Subtract 5. 2n is greater than 3. And then when I divide, I know I'm really getting squished there, I'm going to get that n is greater than 3 halves. 3 halves is fine. 1.5, 1.5, any way you want to write that is just fine. If it said to graph it, and I know it doesn't, I still want to show you these. Since that's 1.5, I would say here's 1, here's 2, here's 1.5. And that's going to be an open circle. And we're going that way. Number 8, again, smaller variable is that negative 4p. So I would add 4p. So I'm going to have 7p plus 4 is greater than or equal to 25. Subtract 4, and I get 7p is greater than or equal to 21. So p is greater than or equal to 3. Filled in circle. Greater than. It's going to the right. Number 7 is where, if this was a regular equation, I would say, ooh, I want you to notice that the variables match. And ooh, I still still want you to notice that the variables match, because this is going to give us kind of a weird situation. When I try to move the smaller variable, again, they're the same. So I would subtract 6h, subtract 6h. I really have negative 18 is less than, 1. And there's no variables left. And that is a true statement. A negative number is smaller than a positive number. But I don't have like a special number. I don't have an important number for like the center of my number line, because everything will work. No matter what you pick for the variable on this one, everything's going to work. So really, this is any real number. And knowing that, that tells me that everywhere on the number line, I'm just going to pick negative 1, 0, and 1. It doesn't really matter what you label on here. Everything works. You're not going to have any open or filled in circles. You wouldn't have any open circles anyway, because everything does work. But I wouldn't even bother putting a filled in circle on that one. In number 9, we have to clean up the left side a little bit. 7j minus 4j is going to be 3j, plus 6 is less than negative 2 plus 3j. Again, oh look, the variables match. So let's get rid of those variables. And I get that 6 is less than negative 2. Well, this time, unlike the last one, that's not true. The variables went away. It's not true. If this was just a regular equation, it would be a no solution. Same thing happens here. No matter what number you pick for the variable, for the j, it's never going to work. If they gave you a number line and said, hey, make sure you graph your solutions, you could do this, or put whatever numbers you want on there, but there's nothing to shade. There are no circles, not open, not filled in, no shading in either direction. There's nothing that's going to work for that problem. For number 10, this last one, I'm going to have 12 times 1/4 w. 1/4 of 12 is 3. So I've got 3w plus 36. 3w, well, look at that, minus 12, or plus a negative 12, when I get rid of my 3w's. I get 36 is less than or equal to negative 12, and that's not true. So that's a no solution. And again, there wouldn't be anything to graph at all for that problem. Today's practice problems are going to be on worksheet 2.4. Make sure you're showing your work. Make sure you're careful with your signs. Be especially careful when you're graphing with open circles versus filled in circles, that kind of stuff. When you're done with that, make sure that you take the formative quiz in Schoology and let me know if you have any questions.